Welcome to Miss Mason Explains Psychological Statistics. All right, so now that you have collected the data, what does it all mean? Okay, you've done your research, you've gathered your data, what does it mean? That is why we do psychological statistics. All right, and statistics are just tools for organizing, presenting, analyzing, and interpreting our data. Now, we do this for many reasons. Here are the reasons. At a first glance, our observations might give us an inadequate picture, all right, a misleading picture, all right? So we have to look at it because it presents a more accurate picture of our data, all right, such as the use of a scatter plot. It also helps us reach valid conclusions, all right? They're a crucial critical thinking tool. Isn't that what we talked about at the beginning of this unit, that we need to use our critical thinking skills so that our data has reliability and I lost my train of thought, sorry. Okay, so there are many tools for describing our data. One of those is through a histogram. A histogram is simply a bar graph. So when you see the word histogram, I want you just to remember it's just a bar graph. Super duper easy. It's a simple way to display the data. However, I have to tell you that this data tool can be manipulated. So look at these two bar graphs. Two different histograms. Why is there a difference in the apparent result? Exactly. It is based on the range that was used. Look, this one goes from 0 to 100. This one's going from 100 to 95. Which one would you use if you were going to say our brand is better than everybody else's? Exactly. You're going to want to use this one. But if you're trying to prove that, brand Z is better than our, like having that discussion. So in reality, yes, our brand of truck is better. However, it's not so different as the others, okay? All right, so just know that the tool can be manipulated. There are 3 measures of central tendency, all right? When you're looking at just one number, to describe a population's income, height, or age, you can use these 3 measures of central tendency. You guys know these pretty easy. The mode, the median, and the mode, the mean, and the median. All right. The mode, I always remember this because it's MO, the most. The most common level, number, score. Okay. The mean, I always remember mean as average. I don't know why. It's been busted into my head. So it's just the sum of the scores divided by the number of the scores. And the median, it looks like the middle, okay? I don't know, it just looks like middle to me. And this is the middle person score or the 50th percentile, all right? Okay. Now, when you're looking at your measures of central tendency, you can put everybody on a line graph, okay? And you can see where is the mean, the median, and the mode, all right? Okay, so we actually note when we put everyone on a line, all right, that there are some skewed distributions, okay? We have some that are outside of here, all right? Now, which one would we use? Right? Which one would I use to describe this neighborhood? So this is a neighborhood and this is the family income. So this is one house, the other house. Okay. Now, these little squigglies that you see here, what do they note? What are these? Exactly. They're breaks and what do we notice about these two? They're freaking huge. Huge income. So what are they going to do? They are going to raise the mean score. Okay, because look, this is the middle and that's the most. That's kind of crazy. So if I tell you, oh, the mean, income of this neighborhood is 70,000. In reality, what can I really say about this neighborhood? Well, it's actually really a low income neighborhood because that's where most of the families are. We just have a few rich little people. Okay? All right. All right. All right. So we just talked about this one. Sorry, I jumped ahead. All right. Now we have measures of variation, and these are how spread out are the scores from the mean. Okay. All right. So how spread out are the scores? So we use range. This is the difference between the highest and the lowest score in your data set. All right. We also have standard deviation, which is a calculation of the average distance of scores from the mean. Now, I am going to tell you that is the formula for standard deviation. Okay. You can watch this wonderful video. I'm going to post it on the Google Classroom. Please watch the video. It's really a great explanation of how to find the standard deviation, what the standard deviation is. All right. And if you have a small standard deviation, you're going to see that your numbers are really close to your mean. If you have a large standard deviation, you're going to see that your bell curve is really flat. It's not as skinny because there are a lot of numbers far away from your mean. Okay. All right. So a normal curve, all right, we're going to look at the normal curve. Here's your mean, here's your standard deviation. They're one standard deviation, negative 1, 1. All right, 68% of your data points should be between 1 standard deviation point away from your mean. 95 should be within 2, and 99 will be within 3, okay, percent, or 3 standard deviations. Okay, now you can have a plus or minus standard deviation away from the mean. Yes, yes, yes. All right. Okay, so again, here's your mean. It's going to be pretty much the same as others. These are probably more than others, probably less. Definitely more, definitely less than others. Okay, we'll use the standard deviation to really look at the significance of your data points. All right. Okay. All right. So when you're looking at your distribution, all right, if it is a skewed distribution, such as in our neighborhood that we've just looked at, you're going to see that your bell curve is not shaped like a bell, but actually, looking kind of like a crazy mountain. Okay. Intelligence test scores tend to be very normal bell curved. Okay, so that's how we define when we look at the normal curve. Intelligence really, really fits the bell curve. Okay, so how can we draw conclusions from our data? Well, we're going to use inferential statistics. We're going to look at the reliability and the significance. Okay, so we're going to ask ourselves, is the difference reliable? Can we use the result to generalize or to predict the future behavior of a broader population? Okay, so how are we going to achieve reliability? Well, we're going to make sure that we have non-biased sampling. Okay, again, make sure that we have random sampling. All right. All right. And make sure that we have random assignment. We're going to have consistency. We're going to check that the data has been collected in a very clear and concise manner. Okay. All right. And we're going to make sure that we have many data points. All right. You want to make sure that you have a lot of data points. If you are talking about the population of Wheaton and you only survey 10 students, do you think that is really going to be a reliable survey? No. If there are 1,500 Wheaton students, you want to make sure that you have as many data points as possible. I'm not saying 1,500 data points, but you might want to have at least 150. Okay? All right. Now, how can we find out if the difference is significant? Could the result have been caused by a random or a chance variation between the groups? All right. And when we find out that something is statistically significant, we're going to find out that data is reliable and that the difference between the groups is large. Okay. All right. So just remember, how do we find out that something is statistically significant? that the difference between the groups is large. The difference between our experimental group and our control group are large, okay, all right, and that our data is reliable, okay. You are going to complete and apply and practice on your statistics, on psychological statistics. Here is my example. So here's my data set, 10, 8, 6, 5, and 6. The mean, I'm going to add up all those numbers, divide it by 5, which gives me the average, the mean of 7. Now when I put these numbers in numerical order, all right, 5, 6, 6, 8, 10, the middle number is going to be 6. The mode, put the numbers again. Which number do I have the most? 6. Now my range, my highest number is 10, my lowest number is 5. Subtract the two from each other, my range is 5. Standard deviation, all right, use a calculator because all right. What's really important to know, is your standard deviation really large or is it really small? This is going to tell you is something statistically significant, okay? All right, and we have a pretty small standard deviation of a positive 2, all right? Okay, so here's the example of what you're going to do for your apply and practice. Good luck, have fun with it. And this is the end of Miss Mason Explains Psychological Statistics.